All right, we're going to talk through a handful of theorems today.
How much?
4, I think.
No, I think 12.
The theorems that we see all year, guys, aren't going to be, they're nothing that's really difficult to understand or recognize by themselves. But the practice that we go through, the situation that we go through, we'll see 4 today. We'll see maybe 5 tomorrow. We'll see 3 the next day, and 6 the following day, and then 2 the next day. And then if I've learned that many over a span of a week, it's hard to maybe come back and realize or remember this one. Does that kind of make sense? So you got to keep on top of things. That's kind of what I'm trying to say here is that you want to learn them well enough that you can recognize that you've done something like this before. So we get to chapter 4, chapter 5, whatever. We're doing a proof, and you're saying, I vaguely remember maybe this type of situation occurring. Let's go back through my notes, my resources, my references, and kind of see how I had kind of interacted with this, or I dealt with this the first time. Maybe reread the theorem, reteach myself that theorem, that concept, and now I can go back to chapter 4, chapter 5, and actually apply it inside that stuff. Does that make sense? If you don't have anything written down, you don't have those notes or those resources, or know where to look, you're going to be stuck in chapter 5 and not be able to get out of it. All right? And that's a hard thing for students to do, is to create notes, to develop notes in a manner that they're useful to you later on. Okay? Because I think it's maybe not until we get 2/3 of the way down through the classroom, you realize, man, I screwed up those first 20 weeks, and I didn't take very good notes, and now I'm paying for that. So hopefully maybe shed light on that a little bit for you before we get to that point. This first theorem, like I said, they're not entirely difficult by themselves. So if 2 angles are supplements of or to the same angle. Supplements of the same angle. Okay? Then the 2 angles are congruent. Okay? If 2 angles are supplements of the same angle, then the 2 angles are congruent. Give you time to write that down. And then we'll break that down into kind of what it means. Okay? Sometimes I think reading the phrases every once in a while might be just congested phrases. And you got to read it 2 or 3, 4, or 5 times, draw a picture to really see what they're saying. When you do that, you're going to find out, oh, that's pretty obvious. That's a very simple statement, simple truth. And it becomes a theorem, or it is a theorem, because of how frequently it shows up later on in other areas. The congestion is clearing up a little bit, but no, stuffy nose. Thanks for asking. That drives me nuts, doesn't it? Squeaking. Uh-huh. No, I didn't kick it. All right, so what we're saying here, when it says if 2 angles are supplements of the same angle, they rewrite that over here as an if-then statement with specifics. Okay? The same angle is this angle 3. Will you say if that's the same in both those statements? All right. So 1 is a supplement to 3, and 2 is a supplement to 3. So these are the 2 angles that are being phrased right there, referenced right there in the if part. If those 2 angles are supplements to the same angle, angle 3, then we can make the connection these 2 angles should be congruent. So let's do this. Let's use some specific values. If I say 1 and 3 are supplements, so let's say angle 3 is 120 degrees. What would angle 1 have to be? 60, right? Pretty straightforward. So that's saying 1 and 3 are supplements. So that should be kind of a situation, no matter what number you chose for that 120. You should be able to find the supplement of that angle pretty easily through subtraction. Now it's saying, now that we already got 120 as angle 3, it says 2 and 3 are supplements as well. What's angle 2 got to be there? 60 degrees. the length between angle 1 and angle 2 now? For both 60, they're congruent angles, right? That's pretty straightforward, pretty kind of maybe almost common sense. And that's the thing, is that a lot of your theorems are almost just common sense, okay? But why do we have to do the proof for them? Because we want to understand the process of making an argument and making a logical kind of progression from one step to the next to get to a conclusion. Because hopefully you guys kind of understand the big idea here, the big scope of this course is that, yes, I want you to learn math, but I also want you to learn ways of thinking, okay, and how you can use this mathematical kind of logic to navigate other aspects of your life, okay, and allow you to make good decisions about things if we have a good kind of pattern of thought, okay. I know you guys see, and it'll be more important to you later on when you start recognizing how it impacts you, but eventually, is anybody interested in politics? Okay, if you're interested in politics, I was the same way in high school, I could do without it, but the more I recognize how it impacts me, the older I get, the more interested I get in it, and then I start to think, okay, a lot of people just take politicians' word for things, okay, and they just let them do their thinking for them, where if we structure the way we think, where we can go back and we can start deciding things on our own because of logical connections that we're able to make within things, maybe we start to decide, no, I don't like the way that this politician is talking about things. I don't agree with that. Maybe that allows me to, kind of thoughtfully vote for who I want to be representing me. Does that kind of make sense? And that's just one example, but there's a lot of things in your life that you're going to want to use kind of a mathematical approach logically to address. So that's maybe another reason why we're doing this stuff, okay? The idea, if you play football, okay, what do you do in preparation to play football? What do you do from November to August? You go to the weight room, don't you? Okay? You're supposed to. You're right. It doesn't look like you have been. But you go, you bench, you squat, you do hang cleans, that kind of stuff, right? On Friday nights, do you ever have to do hang cleans on the 50-yard line? No. You do things in preparation. You do things in preparation for that event, right? So those things are building your body to be able to be successful in that football arena. So then, same thing in mathematics here, okay? We're building your brain, your logical processes so that you can be successful in some other game, some other arena somewhere. Does that kind of make sense? I did. All right, so angle 1 and angle 3 are supplementary. This is the proof of that theorem, okay? The if part says if two angles are supplementary to the same angle. So here we're seeing 1 and 2 are those two angles they talked about, and 3 is that same angle they talked about. Okay, if we read this phrase, we could recognize that we have two different angles, 1 and 2, two separate angles, 1 and 2, supplementary to the same angle, angle 3. So we then prove then the relationship that 1 and 2, the two angles that we started with, are congruent. Okay. The reason I want to do this proof, and you'll find this out to be pretty common throughout the course when we do proofs in class. I'm doing them for a reason. I could have picked this one, or there's 3 or 4 other proofs today, or theorems today we could prove, but choosing this one over the other one was because of the patterns that we see, okay? And I want you to open your eyes to the fact that if I understand where we've been, if I understand what we've done yesterday and the day before, okay, and recognize that I'm starting to get similarities in this current situation that I've seen before, I've experienced before, maybe I can use those previous experiences to help me navigate through this. Does that make sense? That's what you do in everyday life, right? Okay. You come into a conflict with somebody, you say, okay, this conflict is similar to what I've experienced before. How did I approach it before? Was there a good outcome, bad outcome? Good outcome? Okay, I'm going to approach this current situation the same way. How did I approach it before? Bad outcome? Now maybe I adjust a little bit to think about how I deal with the current situation. Does that make sense, everybody? So that's why I want to show this proof to you, or work through this proof with you, because yesterday should have, or hopefully yesterday opens our eyes to how we do this. I'm going to write down my information. 1 and 3 are supplementary. 2 and 3 are supplementary. Statement 2 here, like we've said in the past, when we see his vocabulary words, we need to talk about what they mean to us, right? What does angle 1 and angle 3 being supplementary? What does that produce for us? What can we write now? Say again? Okay, so measure of angle 1 plus the measure of angle 3 equals 180, right? Does everybody agree with that? We've seen that now 3 days in a row. When I say 2 angles are supplementary, we automatically develop that trait. Okay? Now I had another set of angles that were supplementary, 2 and 3. So let's say something similar about the measure of angle 2 plus measure of angle 3 equals 180. Okay? So 3 days in a row, we've encountered something similar to this issue where we get supplementary. And each time we've seen that, this is what we develop. Hopefully we recognize that that's a pattern that's going to be very consistent throughout the year. Definition of supplementary angle. All right, so now this is where we kind of think about where we or what we've experienced before. Yesterday, we experienced a situation where we had 2 phrases like these right here, correct? Okay, and yesterday we talked about if that occurs, let me get rid of this highlighted stuff. Uh-oh. All right, so the idea was yesterday, if we could see if these 2 things were equal, what did that allow us to say about that cluster of objects? Okay, they're equal as well. Okay, so then yesterday we wrote down measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus the measure of angle 3, right? What was that reason yesterday? I heard somebody quietly say substitution. Okay. Substitution. All right, so the last 3 days now, we've seen in one or several proofs in each one of those days, we've seen something like statement 3 here, where we had 2 objects on the left, an equal sign, okay, and then 2 objects on the right, correct? And in each one of those situations, what did we try to do to the left-hand side and the right-hand side? Look. Subtract it, okay? So do we see that measure of angle 3 and measure of angle 3 was that common value that's on both sides? And if we got rid of them, what would we be left with? 1 equals 2. Measure of angle 1 equals measure of angle 2. So when we got rid of that thing from both sides, what reason is that? Subtraction. Okay. Now, when we talked about this yesterday at when we started dealing with the last step of the vertical angles theorem, we kind of walked through the idea that there's a number back here. There's a number right here. Okay, we're saying those 2 numbers are equal. When we compare numbers, we're talking about the size of those numbers, right? That's essentially what a number is. We're talking about the size. Well, if they're equal, that means they're the same size, right? In measure of angle 1, that notation tells us that whatever that number is came from an angle, correct? The notation right here in measure of angle 2 tells me that that number, whatever it is, came from an angle, correct? We've got the same size being identified here. We know they come from the same shape. So if you have two objects that are the same size and the same shape, we call those objects congruent. Angle 1 is congruent to angle 2. When we say same size, same shape, that's how we have defined definition of congruency. If you want to write angles that have the same, or angles that are congruent have the same measure, or angles that have the same measure are congruent, something like that, will be fine as well. Okay? Why do we do this one? Look at, just kind of flip back, if you have yesterday's notes with you, flip back to the proof of the vertical angle theory. Analyze that, look at that, compare it to this one. Okay? So the next one. Okay? So when we did this, we did this proof here yesterday. Okay? See if I can make a comparison here for you. I'm erasing the states or the reasons. Okay? But the reasons will be the same. The only thing that is different here, guys, is this first step, right? Get rid of that. It's everything else. Now, I don't know if the 1 and the 2, the numbers might change. In the way we talked about the angles or identified the angles might change. But these procedures, okay, steps 2, 3, 4, 5, and 6 are the same as 1, 2, 3, 4, 5 here. Okay? And that's my argument with you that I kind of tried to discuss before we did the problem, is that your previous experiences are going to help you navigate your current situation. All right? And mathematically, we see that all the time. Okay? We see patterns. We can recognize those patterns. Hopefully, that allows us to move through some proofs a little bit more efficiently. All right? Is that okay with everyone? See that? Make that connection? This idea here that we use with that congruency, not congruency, that I guess that equation here and that equation there, and we then set them equal to each other using substitution, that happens all the time. Okay? That's a very, very common approach or component to a lot of different proofs. Okay, so that then hopefully shows you the reason why we can say that previous theorem is true. This then is another theorem that follows kind of directly from that. Whenever we talk about like supplementary ideas, we can always then kind of convert over to complementary ideas, or vice versa. If I start talking about complementary, make a relationship against complementary, usually the same type of relationship exists in regards to supplementary. Okay? They're kind of like cousins. Okay? There's similarities between complements and supplements. So this is the exact same theorem as before, but we took the word supplements out and replaced it with complements. Okay? Took the word supplements out, replaced it with complements. Eggs. Yep. 3. Yep. Call me fat. All right, so if you compare this to the last theorem, they are identical, except for that word supplements and complements, right? So when we do our proof, what do you think is going to exist inside this proof? What's it going to look like? Okay? Okay, so your first phrase in the last theorem, the last proof we did, instead of saying 1 and 3, or sorry, 1 and 2 are supplementary, it's going to now say 1 and 2 are complementary, right? And in the second one, it's going to say angle 3 and 2. Instead of being supplementary, they're going to be complementary, right? Then, the next two phrases where you did your algebra, when you said 1 plus 2 equals 180, what's he going to say now? Yeah, it's going to say 1 plus 2 equals 90. That's the only thing that is different in regards to the proof we just did and the proof to this one. Okay? So I'm not going to do this proof with you. I think it's safe for an exercise in your homework. But you might want to put a star here on this theorem and say, hey, prove this the same way as the last theorem, but the 180 changes to 90. Okay, something like that. And that can help you later on, I think. Okay? Help you with your homework especially. You see that? You do see this one in your homework. But they kind of guide you. They structure the parts of the proof. They give you some of the parts already. All right, so some theorems that are just kind of almost common sense. Okay? Some theorems that are almost more common sense than even the last two. This one says all right angles are congruent. If I gave every one of you a right angle, could every one of you take your right angle and put it on somebody else's right angle? And they match up perfectly, right? And you can do that. It doesn't matter what angle it is. If I say you all have a 30-degree angle, can everybody take a 30-degree angle and put on anybody else's 30-degree angle? Would they be congruent? Okay. But the idea is that the 90-degree angles, the right angles, are angles that are more prevalent. This property, this idea is used more often than maybe a 30-degree angle or maybe a 52-degree angle or something like that. Okay. So we like the idea of having the ability to say, if I have two right angles, then they are congruent. Okay? If I have two right angles, then they are congruent. And that, hopefully, is common sense and by itself, not hard to understand. And later on, you'll see that we have a lot of statements like very common sense ideas. But we get them, we struggle with them collectively because it's a common sense idea amongst maybe 200 other statements that are also common sense. Is that all right? All right, so I'll give you one more theorem, and then we'll do some practice problems. This says if two angles are congruent and supplementary. Congruent and supplementary. So if they're congruent, they got to be the same, right? If they're supplementary, they got to add up what? 180, right? So if they're the same value, but they add up to 180, what do they both have to be? They both have to be 90. If they're both 90, they're both what? They're congruent, but they're both 90, they're both right angles. Okay, we can classify them now. So when you have two angles that are congruent and supplementary, you automatically have two right angles, right? And that's the same regardless of, what they add up to. If I have two angles that add up to 60, do you automatically, and they're congruent, you automatically know they're both 30? If I have two angles that are complementary and they're congruent, do they both have to be 45? Yeah, so this is true regardless of what their total is, but we see this more often than anything else, okay? The idea of having two angles congruent and supplementary at the same time, then we know they both have to be right angles. Okay? We all right with that? All right, so I want to do some algebra problems then. These theorems, as we introduce them, we'll mess around with them, we'll prove them, but they're going to show up maybe tomorrow, show up a little bit maybe in the next section. Some of these we might introduce today and it show up in today's homework. We address it in today's homework, and then we'll go 15 weeks before we see it again. It's just the way things are. And if it's 15 weeks before we see this again, we're probably not going to it's probably not going to be on the tip of our tongue, right? It's not going to be in the front of our brain when we're thinking about this stuff. So what would we want? We would want to have the ability to at least say, I remember something about that. Let's search through our notes and see what that something was. And now I can regain an understanding for it and go back to my current situation and apply it and use that property then. Okay? So our notes need to be things that are organized, that we can navigate through pretty easily when we get to a situation where we need some assistance. All right, so I want to do one of these. These are kind of just the traditional, kind of easier questions that are attached inside this section. And usually this section is going to, when we have an equate, I guess a theorem that equates things, okay, a lot of times we'll then say, okay, let's practice that with some algebra. So our vertical angles theorem is really what this one's targeting, okay? Our vertical angles theorem equates two angles, right? So what they're trying to get you to do is recognize that with vertical angles, I can say that that angle and that angle are what for us? Very cool, right? So does that give me the ability real quick to solve for x? All right, so x ends up being 38. Okay, divide both sides by 2. So now if I know x is 38, I'll automatically know if this is 76 degrees here. Do you have the ability to tell me what y is? What's the relationship between y and either one of those 76 degree angles? I should have 180. It should be supplementary, right? It's a linear pair right there. So y should be 104, correct? Okay. Hopefully that's a kind of a routine problem that we can see. I want to show you and explain to you this. Okay, so I don't like just showing you guys and you guys working with me. I don't want to say show, but I don't really just like working on problems and practicing them and just getting answers. I don't think that's beneficial. I want to talk about why we go the route that we go, okay, or what opens the door for us to use certain routes over others. Okay, so I want to approach this question as if we were doing it before we knew anything about vertical angles. So I don't want to use any vertical angle relationships here to do this problem. Okay, and hopefully that then opens our eyes to the benefit of having that property, having that theorem. So if I were to not know anything about vertical angles, my only option would be to look at maybe this angle here and that angle there, right? You guys agree with that? Okay. What was your relationship between them? They add to 180, correct? So we should be able to say 3x. Write the whole thing out here. 3x plus 8 plus 5x plus 4y equals 180, right? Now, if that's the case, we should recognize that there's some like terms there, right? So let's condense that. Let's make that a little bit better of an equation. So I'll say this turns into, what, 8x's, 4y's. Now this 8 and this 180, can I move that 8 over and get 172? All right. So my hope is that we can do that. We recognize that. That's some algebra 1 stuff there. Okay. Now, why is that equation problematic for us? 2 variables. Good. Okay. So we can't solve and get a numerical result for either of those right now. Okay. We could isolate x and solve x in regards to what y is. So I can isolate x. I can subtract 4y from both sides and divide everything by 8, right? And that would get x, 1x by itself. But then on the right-hand side, I still have an expression with y. I could do the same thing for y. Get y all by itself, get a 1y, but then the right-hand side will be an expression in regard to x. Okay? If I have something like this, if I have an equation with 2 variables, the only way that I can solve that numerically is to develop another equation that has the exact same 2 variables. So when we look in this picture, would you guys agree that angle and that angle are going to have some relationship with one another? Okay. Again, trying to approach this without having any understanding of vertical angles. So when I add those together, okay, I get 5x plus 4y plus 5x minus 20 should equal 180, right? Doing the same thing here then. Add my x's together. I've got 4y. I'm going to add my 20 to both sides. Gives me 200. You guys agree that that's what that blue equation kind of transforms into? All right. Now, you did this last year. Okay? You guys remember last year taking this black equation, taking this blue one, put the plus sign right there, putting a line down here, and now you try to add these columns, add your x's together, add your y's together, add your constants together, and the hope was what? Something would cancel out. You would have additive inverses. You would have a positive 4 and a negative 4. Or you have a positive 8 and a negative 8, or positive 10 and negative 10. That's not going to happen here. If we add straight down, we get 18x plus 8y. So we learned last year that we can manipulate any equation that we want to, as long as we do it to every single term in that equation. Multiply by any number you want to. If we think about that, if I multiply by any number I want to, if I multiply by a fraction, it means I can also divide by anything I want to. You can multiply or divide these two equations by anything that you want to. I think it probably makes sense to multiply one of these by -1. So I'll multiply the top one by -1. That changes every single time. Okay? Now when I add straight down, -8x plus 10x is 2x, right? -4 plus 4y, let's cancel out. That's the elimination aspect. And this is going to give me 28. So what's x going to be? 14. You guys think that was a lot of work to find x? Okay, I totally agree with you. 100%, a lot of work to find x. Now, there is work yet to find y. We'll talk about that in a minute. But let's now approach this question of solving for x in regards to knowing the vertical angle theorem. If I know the vertical angle theorem, what can I say about that angle and that angle? They're the same. 3x plus 8 is equal to 5x minus 20, right? Is that going to solve for x? Subtract 3x from both sides. Add 20 to both sides. You still get x to be 14. Much quicker, correct? All right, so the benefit of theorems, the benefit of these extra properties is to allow us to navigate these questions quicker, okay? It's to provide, it's going to open more doors for us. Does that make sense? Okay? The more pathways that I have to answer a question, it's going to, obviously, one of those is going to be quicker than the other, okay? This one here, this problem is quicker than the other. And that's kind of what we go through the entire year, is try to learn more and more properties that allow us to develop relationships. And we might have, at some point, 4, 5, 6 different ways to answer a problem. Obviously, one of those is going to be quicker than the other. And the more properties that I know, the more I'm going to be able to address which route is easier, which one's quicker. Okay? Now, both are right. Both are fine. All right, but if I gave you like 3 of these on a test or quiz, somebody that's using elimination every single time because they're robotic and they're not thinking about what they're doing and thinking about the math that is involved as they start writing this stuff down, they might exhaust 25 minutes on these 3 problems. Where a person that uses their properties appropriately, maybe it takes like 5 minutes to do those 3 problems. Does that make sense? And that's the thing. And every year I get people run out of time on homework, or not homework, tests and quizzes because of that idea. Okay? We're learning these properties so we can be more efficient with our approaches. All right? So now that I know what y is, now I know what x is, I want to find y, right? If I was using this elimination process, you guys remember last year, all you have to do is take that x value and plug it back in to any one of the equations that you've created before. Okay? I know that I can multiply 14 by 10 better than I can multiply 14 by 8 in my head, right? Make sense to everybody? So I'll plug into that blue one. If I plug into that blue one, we'll get 10 times 14 plus 4y equals 200. So that's 140 plus 4y equals 200, right? Move my 140 over. So what's y got to be? Y is 15. Okay? Now, if I was using the vertical angle approach, I got that 14. Maybe I don't even maybe I don't have any of these 2 variable equations set up. But now that I got 14, can I come back up here and say, well, this angle's got to be 50, or this angle's got to be 50, right? Okay. If that's 50, maybe this one's got to be 130, correct? Can I say that either, and it's 5x, that's 70, isn't it? That makes sense, everybody? Plug in the 14 there. So I got a couple options. I could say 50 plus 70 plus 4y equals 180. Or can I say 130 is equal to 70 plus 4y? Can I go that route? If I do that route, or either route, doesn't matter, I'll get 60 equals 4y. All Well, that's the same thing I got right here, correct? Okay. So the hope is that we can recognize different approaches and start being thoughtful about the approach that we take. Okay? Every time I look at a problem, guys, I try to analyze. It shouldn't be something we sit and look at. I want to look at that first one there, 33. I don't want to sit there and say, okay, 4, 5, 6, 7 minutes and try to decide which route is the best. Because each one of those routes should be able to be conducted in under 6 or 7 minutes. Okay. So if I have to sit and really, really think about it, I'm just going to choose something and go with it. Okay. So I think I can look at this right now and say, okay, maybe the vertical angle aspect here doesn't help a whole lot because there are 2 variables now, right? The one thing I like to do a lot of times if I'm trying to decide if there's an easier approach is I write the equations that I know exist. I know 2x equals y minus x. That's setting up these vertical angles, right? Okay, that's great. But it's 2 variables. Kind of stinks. So then I look for other relationships. Would you guys agree there's a relationship between those 2 items? Okay? So I go 2x plus y plus x equals 180. And those are supplementary. Now, if I had those 2 blue equations, they both have x in them, they both have y in them. So I could ultimately, with those 2 equations, go through all the elimination or substitution procedures and solve for x and y. But is there one more relationship up there that I don't have written down? This one, right? When I add those together, what's going to happen to my x? They cancel out. I add those y's together, 2y equals 180. Do you see the benefit of having all these options? Because now that equation opens the door to solving for y right away. Y's got to be 90. So now if y is 90, this is also nice that I've written the other equations, because now when I know what y is, I go up to any one of these and figure out the rest. I'll put 90 in right here. You add x to both sides and get 3x equals 90, right? That's got to be 30. If I come here and put 90 in for y, I have 2x plus 90 plus x. That's 3x plus 90. Move that 90 over. I have 3x equals 90 again. Still get x to be 30. Okay? And the more you do these problems, the better you understand your properties. You'll be able to sit and say, okay, I look at 33 and I see that y plus x and y minus x right off the bat. And I know that's going to be a better approach than anything else because there's opposites there. Inverse operations occurring there. If we do 34, I don't see anything like that happening in 34. Okay? But I do see that when I set this up, y equals 2x, right? That's a nice thing because if y equals 2x, couldn't I relate these 2 things? And wherever I see y, replace it with 2x, and then I'll have an equation that has just x in it. Okay? So as we move throughout the year, guys, you're going to see more and more of these properties that develop these relationships that we're going to want to try to go through these problems and use those relationships appropriately to save a little bit of time. What stinks about that in problems like this, there's not one just got to do it this way approach like there was in Algebra 1, right? I'm going to factor x squared plus 4x plus 4. There's one and only one way that I'm really going to do that. Okay, so everybody's on the same page. Question 34 up there, there might be 3, 4, 5, 6 different ways of doing that, and they all be okay. So when we're going over them in class, I like to try to exhaust and show you, okay, if you do it this way, you're okay. If you do it this way, you're okay. If you do it this way, you're okay. And that might be monotonous, but I think it's good for us all to see the different approaches. Okay? Is that okay with everybody? All right, my suggestion to you, as you got a homework assignment tonight, I'm leaving it open until Monday. It's not going to be due until Monday. I haven't decided 100% what I want to do tomorrow. My suggestion is that when you guys see theorems, okay, write them down, obviously in your notes, but then go home and look at those a little bit, okay? Maybe write them down on flashcards, okay? Put them in flashcards. Develop a cluster of flashcards, and then you got free time every once in a while during school, okay? Last 3, 4, 5 minutes in class. Bust those things out and just read them, okay? It's going to make your life a little bit easier, especially as we start making this course. Hopefully you guys think the course so far is not too bad, right? Okay. It will be like overnight that things start getting harder, all right? If we take the steps necessary now and not just kind of rest on our laurels, we'll be better set up for when it does get hard, but we think, oh, this isn't really that bad, okay? But it will get more complex as we start attaching more theorems and trying to use those and pull from those.